Okay, this video is for Reconstitution. So when a medication in a vial or in a bottle comes in a powdered form, we have to add a sterile liquid or saline or water, and that's called the diluent. And when we add that diluent to the powder, it's called reconstitution. So the process changes the powder form to a liquid form. And these types of medications tell you what and how much to reconstitute with. So after reconstituting with the proper diluent, you will need to determine the concentration. And if for any reason the concentration is not listed on the vial or bottle label, you would use a reference or a drug book or packaging insert, or you can call the pharmacist. But for all of these problems, you have to be able to identify the concentration to determine what the dose is in that reconstituted form. So for this class, the concentration is provided to you in the questions. So if I were to say to you, you have 2 apples and they're mixed with 3 oranges, it means that there's 2 apples and 3 oranges. If I were to say to you 500 milligrams of powder mixed with 10 milliliters of sterile water, it means there's 500 milligrams in 10 milliliters. And that's pretty much what the concentration is after you instill the diluent. So the vial will say maybe 1 gram you put in, and it tells you to instill 10 milliliters, it's 1 gram in 10 milliliters. So let's look at this problem. A medication is supplied as 120,000 units of powder. This is how it's supplied. The label says to reconstitute with 5 ml of diluent. The order is a dose of 75,000 units. And the question asks, what will you give? What will you administer to the patient? So the first thing, we always look for the given, and the given is the order. But please read your questions. Don't get confused. This here, 120,000 units, is not the order. It's saying that's pretty much what the label is supplying. It's 120,000 units of powder, and there's a label on it. What is ordered is 75,000 units. So we start with 75,000 units. And this is much like the 1 factor. All right, you can put that over 1. So the ordered dose is 75,000 units. So what is our wanted? Well, if we're adding liquid to a powder, our wanted is the milliliters. You can put that over 1. And remember why? So that reminds you that milliliters has to end up in your numerator. So what can I use in my problem to get rid of units and get just to milliliters? Well, remember when I said 2 apples mixed with 3 oranges is 2 apples and 3 oranges. Well, 120,000 units mixed with 5 milliliters is basically saying there's 120,000 units in 5 ml. That is exactly what that means. So I can use this in my equation. 120,000 units in 5 milliliters. So now I can look at my problem. I've used this, I've used that, I've used that, and I've used that. I can cross off my units, and I'm left with milliliters. That's exactly what I want. When I look at my problem, there's nothing left in my problem other than milliliters. So now you know it's just math. So 75,000 times 5. I'm going to have to break out my calculator. 75,000 times 5 is 375,000. And 120 times 1 is 120,000. When I divide 120,000 into 375, it gives me 3.125. And my rounding rules, 1 to 10, I round to the tenths. 2 is less than 5, so I do not round up, I'm sorry. So my answer is I'm going to administer 3.1 milliliters to this patient. And that's what I'm writing on my answer line, 3.1 milliliters. When we look at this problem, it's telling you, add 5 milliliters of sterile water to a vial containing 1 million units of a medication, and it's in a powder form. Then prepare 675,000 units for injection. So what is my order? Well, my order is prepare 675,000 units. That's the order. That's my given. 675,000 units over 1. What is my wanted? Well, if I'm adding a liquid, my wanted is the milliliters. Put that over 1, so it reminds you that this has to be in the numerator. So what can I use in my problem? Well, it's saying 1 million units, and I'm adding 5 milliliters to it. So that means that there's 1 million units in 5 milliliters. And that's exactly what I'm going to use in my problem to solve it. So 1 million units in 5 milliliters. That enables me to cross off my unwanted, and I'm left with my wanted. So now, it's just math. So if we do the long math, and I know some of you were able to cross off your zeros, that's awesome. I'm somebody that has to do it all. So 3,375,000, and this is 1 million. And when I divide that into 3,375,000, it gives me 3.375. My rounding rules, round to the 10th, 7 is greater than 5. So I'm going to give that patient 3.4 milliliters. And that is my answer. So in this problem, it says a medication is supplied as 1 gram of powder. And the label says reconstituted with 8 milliliters. So again, what does that mean? There's 1 gram in 8 milliliters. The ordered dose is 750 milligrams. So my given is the order, and I start with my order, 750 milligrams. Put that over 1. What is my wanted? Well, it's got to be milliliters because that's what is being supplied. So I'm adding 8 milliliters of a diluent to this powder that is 1 gram and 8 milliliters. But my order is in milligrams. So right away I'm thinking I need to do a conversion. 1 gram is equal to 1,000 milligrams. So I'm going to use this in my problem as well. So I've already used this. So now let's get rid of the milligram because I got to get away to get to milliliters in my numerator. So there's 1,000 milligrams in 1 gram. That gets rid of my milligrams. So now how am I going to get rid of my grams? I'm going to go to my problem. There's 1 gram in 8 milliliters. That gets rid of my grams. It leaves me milliliters, and that's exactly what I want. All of my units have been canceled out that I don't need, and I have exactly what I need. So now it's just math. So when I multiply 750 times 8, gives me 6,000, and 1,000 times 1 is 1,000. When I divide 1,000 to 600, I am going to administer 6 milliliters, and that is my answer on the answer line. All right, here's another example of a reconstitution question. So pause it here if you want to try it by yourself, and then come back and see if you got the answer right. So it says add 2.5 milliliters of sterile water to a vial containing 100 milligrams of a medicated powder. So right there, I should be thinking, all right, 100 milligrams in 2.5 milliliters. Then prepare 40 milligrams for injection. What am I going to give? What's my order? Prepare 40 milligrams. Put that over 1. What's my wanted? Well, if I'm giving an injection and I'm adding a liquid, it's milliliters. So how am I going to get rid of the milligrams? Because I have to get to milliliters. I use what's in the problem. 100 milligrams in 2.5 ml. That gets rid of my milligrams. So now it's just math. 40 times 2.5 is 100. And 100 times 1 is 100. So I am going to give 1 milliliter to that patient. So here's a problem that has a lot of information in it, and it's not uncommon to see vials that contain different units of measure to tell you how the reconstitution is. So when you look at this question, it says medication is supplied as 1 gram of powder, and the label says you're going to reconstitute 10 milliliters of a diluent. So that is 1 gram in 10 milliliters, right? So after we reconstitute it, the vial may also say it also contains 100 milligrams per ml. The ordered dose is 0.5 grams. So So why does it offer this when I work so hard to get this? Well, in reality, if you were to change 1 gram to 1,000 milligrams and did a whole conversion, these two equal the same thing. They are absolutely identical in their problem. So it's providing you 2 different units. So you could do less math. So when we figure out our problem, let's start with the given. What's the order? It says right here, the ordered is a dose of 0.5 grams. All right, put that over 1. What is my wanted? Well, it's milliliters because that's how it comes. I'm adding a liquid. So how do I solve this problem? Well, I can use this or I can use this. And I'm going to show you the easy way first. Well, after I did all the work and reconstituted, 1 gram is equal to 10 milliliters. That gets rid of my grams, and now it's just math. So 0.5 times 10 is 5, and 1 times 1 is 1. So that's 5 milliliters. I'm going to give 5 milliliters. But let's say I wanted to use this one instead. And I'm showing you this because in practice, you will see this. All right. In practice, you will see different reconstitutions on a vial. So what if I wanted to use this one? No problem. I still start with my order, 0.5 grams, put it over 1. I'm still solving for milliliters over 1. But now I have to do conversions if I'm going to go milligrams to grams. So I can say 1 gram is 1,000 milligrams. And 100 milligrams is in 1 ml. And what you'll find is when you do the math, 0.5 times 1,000 is 500, and 100 times 1 is 100. It gives you the exact same answer, 5 milliliters. I just want you to be aware of this so you don't try to use both of these in your problem. All right, it's one or the other. It's telling you after reconstitution, the vial also contains this, which is exactly the same as 1 gram and 10